All right, sorry, the last video got snipped, so we're just gonna jump in where we left off. To summarize, we had this equation, different components went into it to give me this, did the characteristic equation, got sines and cosines with 5 t's. That was linearly dependent on the force that was being applied, so we had to bump things up with these t's, at, sine 5t, and bt cosine 5t. So we need to start taking some derivatives. We want to derive this twice, run it through this equation, and set it equal to this right-hand side. There's definitely some product and some chain rule, so you got to be careful to make sure you're precise as you're going through. Okay, so xp prime is equal to, all right, I got the derivative of the first. Well, the first is going to be t, so the derivative of that is 1. So I get a sine of 5t plus, all right, the derivative of the second one here is sine of 5t. So I get 5at, I carry the second along, cosine of 5t. From there, I'll just bring this over here. From there, I need to do product rule again on this one. So I get plus, all right, I get b cosine, not sine, cosine of 5t plus 5 bt sine of 5t. It's a negative here because of chain rule, so this 5 pops out front. I want to double check that I did that right. Ba-doop, ba-doop, ba-doop. All right, we got that piece. Looks good to me. So always double check these steps. All right, so xp double prime is, all right, derivative of this one first. That gives me 5a cosine of 5t with some chain. Next one, I get 5a cosine of 5t. That's the same thing as the other one. And then I get a negative from my chain, or from my product here. I get a 25. I get my at, it comes along. And then the cosine turns to a sine, and I get a 5t on the innards. And then I'm going to get, I'll write down, so that this stuff right here is all the derivative of these things. Now I'm going to go and do the derivative of these things down here. So I get minus 5b sine of 5t, some chain. And then I get another minus 5b sine of 5t. And then I get a minus 25 from the chain. B, t comes along, cosine of 5t. All right, so I'm going to go ahead and simplify this. I have 10a cosine of 5t. This is xp double prime. Minus 25a t sine of 5t. And then I've got my, I have minus 10b sine of 5t minus a 25 bt cosine of 5t. Okay, so from here, I need to plug, I'll zoom out so we can see everything here, this and this into these two pieces right here. So let me actually get rid of these little underlines. If you look here, the x double prime gets multiplied by 2. So that means that this line needs to be doubled. Additionally, the x here needs to be multiplied by 50. Let me... So and then I'm going to plug that through and then set it equal to this stuff over here. So I'm going to go in the order in which it has it here. So I get 2 times this whole thing right here. All right, that gives me 20a cosine of 5t minus 50a, 50at sine of 5t minus 20b sine of 5t minus 50 bt cosine of 5t. Next, I got to do 50, this right here, times this line. So in purple, I'm going to have that line times 50. So I'm going to get, and I'm going to come down below so that it kind of, we can see everything. So I get, this is a continuation of the line that I have in red there. So I get plus 50AT sine of 5t plus 50BT cosine of 5t. And then that gets equal to what I have here on the right-hand side of the equation. So that has to be equal to 3 sine of 5t minus 2 cosine of 5t. All right, some really nice things happen here. So let's just go so we can see that line right there. All right, look, I have a 50AT sine of 5t, and it's negative. I also have, oops, I'm missing 50A. I also have that piece right there. So, no, sorry. Yeah, that's correct. So this, oops, let's go in blue. This is going to cancel with that. Anytime we have a resonance problem and we have that extra t piece term, something like this should happen. I also have this canceling with this. So I get a really nice simple equation at the end here. I get 20a cosine of 5t minus 20b sine of 5t is equal to 3 sine of 5t minus 2 cosine of 5t. If you take a look here, it should be pretty obvious. All right, the sine term on this side is a 3. Well, the sine term over here is a minus 20b. So I get minus 20b is equal to 3. You can solve that and get that b is equal to negative 3 over 20. I can do the same thing with the a. Whoops, get out of here. Having technical difficulties. 20a is equal to negative 2, because those are the two cosine terms. So I get 20a is negative 2. Gives me a equals negative 1 over 10. So we're going to back out a little bit here. Remember, this was my xp right here. So x of t is equal to xc plus xp. So xc is equal to what I have right here. So that gives me c1 cosine of 5t plus c2 sine of 5t plus, all right, my xp now. So to do that, I'm using what's in this purple box right here. A is negative 10, so I'll actually write minus. So minus 1 over 10 times t times, that's a sine of 5t. And then the next one's also minus, so minus 3 over 20 times t, over there, right, this piece, times the cosine of 5t. All right, so the last thing I need to do, you may be like, all right, we're finally done. Well, not so much. If you look in at the problem right here, it starts at an equilibrium position of 0, of a position of 0 and a velocity of 0. So I have to use those initial conditions to find my c values. Now, this is set up pretty easily to let us do that. So if this is x of t. I know x of 0 is 0, and I'm going to use that first. So 0 is, now watch, look. I'm going to plug in t for 0 for these. These last three terms are all going to go to 0, which is really nice. So that's going to give me 0 equals c1 times, all right, cosine of 0 is 1. So it's just c1 plus, all right, c2. This term goes away because the sine of 0 is 0. Same thing with this one. Sine of 0 is 0. And then this last one has a t out front. So when I let that be 0, I get 0 there as well. So that tells me that c1 is equal to 0. So what I can do is then take the derivative of this, and I can ignore my c1 term. If I do that, I get that x prime is equal to, all right, so this term is 0. So I get a 5c2 cosine of 5t. And then this stuff has to have some product rule on it. So we get minus 1 over 10 sine of 5t minus 5 over 10 from the chain rule, t cosine of 5t. That term's not going to matter because the t here is going to make it be 0. Same thing over here. This term's going to 0 out. All right, so this gives me minus 3 over 10 times cosine of 5t plus 3 times 5 is 15 over 10. And I know it simplifies, but it's going to go away, so I'm not even going to bother using any time to do this, to simplify. T times sine of 5t. And this is that's the correct sign. All right, so from here, look, again, lots of things go to 0. This one goes to 0 because of that. This one goes to 0 because of that. This one goes to 0 because of the sine of 5t. This goes to 1 as this goes to 1. So you can see that I get x prime equals, when I plug in t equals 0, I get 0 equals 5c2, not c squared, c2. And then all of this stuff is either 1 or 0, come through, minus 3 over 10. So from there, almost done, I just need to algebraically solve. So, careful, you may have caught that this should be a 20 and a 20, which makes this a 20 here. All right, so we're almost done. Move the 3/10 over, positive 3/20ths. Jeez, man. 20 equals 5c2. Divide by 5, I get c2 equals 3 over 5 times 20 is 100. So, that's it. I just have to now write my solution. X of t is equal to, all right, c1, 0. So I get c2, which is 3 over 100 cosine of 5t minus 1 over 10 t sine of 5t minus 3 over 20 t cosine of 5t. That is the end of this resonance problem. I hope the logic makes sense to you in terms of like all of the different steps that we take and why we take them, and that you can do these yourself. See ya.